In this video, we're going to talk about the macro package. And the setup for this package is a little bit different than most packages, so let's walk through it from the beginning. First, we'll just install the package. This package is on CRAN. You can install it in the normal manner. And now, once it's installed, if you go up to your add-ins menu, you'll see there's a macro section of the add-in menu. And there's two items here, macro source and macro source with debug. And the purpose of these menu items is so that we can map keyboard shortcuts to them to make using this package easier. So now let's go map the shortcuts. If you go up to Tools, Modify Keyboard Shortcuts, and then search for macro, you'll see those two same menu items here in the keyboard shortcuts dialog. And what you can do is put your cursor in this shortcut column and then press Control M. That's a small m, not a large M. And then Control D, small d. And on my keyboard, these two shortcuts are free. They don't map to anything else. If they happen to be mapped to something on your keyboard, then you probably should choose different shortcuts. So I'm going to apply that, and if I were to now put my cursor on a program and then press Control M, it would run that entire program. But what it also allows me to do is highlight a section of code and then run that in isolation. And this is very useful. And that's what I'm going to do right now, is step through chunks of this program by highlighting it piece by piece. So I just ran this section of code right here, and you can see what it does is just assigns this macro variable A the value hello, and then uses that macro value ampersand A in line 9 here. And anyone from the SAS world will understand exactly what's happening here. The only real difference is that these macro statements are prefixed with a comment symbol. These statements have to exist in comments because if I were to take this out and start it with a % sign, then RStudio would complain. So in the macro package, all the macro commands are prefixed with a comment symbol. And other than that, it's very, very similar to SAS. Now, one thing that's a little bit different is that when that piece of macro code ran, it sent something to the console. And here what it sent was the resolved macro code in between these two lines, and then the output of that code. Let's go to the next piece. This is a macro condition. So here I'm going to just set this macro variable B, and if it's 1, then I'm going to execute this print statement, and otherwise execute this print statement. So I'll press Control M, and you can see what happened was that the first condition was emitted, and then that print statement ran, and it printed that string. Here's a very simple macro do loop. Now here's the little macro function. All we're going to do is pass in a value and print that value, pass in the value hello, and we print that hello. So these are the most basic elements of a macro language: a assignment, a condition, a do loop, and a macro function. This next set of examples is looking at some built-in macro functions. One of the things that sometimes happens when you're working in a macro language is that you need to get a value from the regular language. And in SAS, this is frequently done with proc-SQL or with a data step symput. Here in the R macro language, we have to do something a little bit different. So there's a %symput function, and what this does is go pull a value from the regular R language and assign that value to a macro variable. So here I'm assigning this variable A with the string goodbye, and then the %symput function is going and getting that A and assigning it to the macro variable B, and then printing the value of ampersand B. which is that macro variable sitting in the symput table that we just created. So let's run this code. And you can see in the console the code that got resolved and that we printed that value goodbye. Here's another built-in function, this r-str. This is a macro quoting function. It prevents resolution of whatever's inside the parentheses. Here we have the value $b. There's another $b over here. And what will happen when you run this is that the first $b does not resolve and the second one does. And that's because that r-str prevents resolution. Here's the sim exists. This is simply looking for the existence of a macro variable. You don't have to quote this or do anything. You just pass the macro variable name that you're looking for and it'll tell you whether or not it exists. And here's a couple of expressions. What we're going to look at, here's the sysfunc. Again, anybody from the Sass world will know exactly what this does. So this macro variable C is being assigned this little expression, max of a vector. D is being assigned the same max of a vector, but this one is wrapped in a sysfunc. And what that will do is evaluate that little R function, the expression, so that we see the resolved value 5 instead of the expressions. Here's a few functions for working with the symbol table. The macro symbol table is part of the macro package. It's running in the background all the time. And it holds all the macro variables that we've been creating in these few examples here. And if you wanted to go see what they were, what's the value of the things in the symbol table, you just run this symbol table function and it'll print those out for you. This is coming back in a list. If you wanted to assign it to something and go use it programmatically, you could. Here's another one, simget. If I wanted to just pick out a particular macro value, you can do that. And here's a simput. If you want to assign a macro variable a value from regular R code, then there's a simput function to do that. It's quite similar to the %simput that we saw in the previous example. But here, this time I'm running from regular R code. So from regular R code, you can create a macro variable, or you can sort of pull it from regular R code with the %simput. Now that I've created that E macro variable, I can go see that it exists with my symtable function. And if I wanted to clear out that symbol table, there's a symclear function where we can kill everything in the symbol table. You can see that it's now gone. So those are a lot of the basics of the language. So now let's do something a little more interesting. This is a template analysis program. And what I've got here is a macro function that can do some analysis on a data set. And it's set up sort of dynamically so that you can pass in what the data set is, what the variable that you want to analyze is, and even like a list of statistics that you want to perform on that analysis variable. So what this does is sets up this macro function and then loops through the analysis variables one by one and then calls that getAnalysis function and then combines the output of all those analysis into one final data frame and then prints that final data frame. So this is quite a dynamic little program. Even though it's very short, it sort of demonstrates how this package can be useful. This thing that we're doing is called metaprogramming. We're creating a program dynamically, passing in values dynamically. And what we're doing here would actually be a little bit challenging if we were just working in base R or tidyverse alone. And the way we're going to call this template program is with this driver. There's a few different ways to do this. The way I'm doing it here is I'm just going to call my macro package, set up the path to that template program. The input variables to that template program I'm going to assign with this simput function. And then I'm just going to msource that template program. And msource is the main function in the macro package. This is the one that runs the preprocessor, creates the generated code, and then executes the generated codes. When you're pressing that Control M behind the scenes, this is really what you're getting is the msource function. And you'll notice that in this code right here, there's no macro functions or macro variables at all. This is just standard R code, and that means that I can run it just with the source function. And that's the main reason I did it the way I did here, is because the driver program can then be sourced normally just in RStudio. And so I just sourced that driver, and now I can go look at my generated code here. You see that what I assigned the data set was the empty cars data frame that comes with base R. And the variables that I assigned were these, and the statistics I assigned were these, and that all those replacements have been made in the template program. The data set, the variable, and the statistics list, only those statistics that I asked for have been emitted into the resolve code. Coming around that loop, there were 3 different analysis variables, and you can see there's a little block here for each analysis variable. Again, this is a text replacement and generation system. So everything you do results in some generated code. Each one of those blocks created a data frame. Those data frames got combined with the bind rows here, and then that got printed. And here's the results with one data frame with all of my analysis variables and the statistics for each. And you'll notice in my driver here that I had this file out parameter. This is telling the msource function that I actually want to save my generated code. And so that got saved into x4out.r, and we can actually go look at that. It's right here. So this is the generated code file that I can now run completely independently of the macro language. And now let's do it one more time, but this time I'm going to pass in completely different parameters to that template program. I'm going to pass this time the iris data frame, a few different variables on that data frame, and a little bit different set of statistics. One thing I want to mention is that on this msource function, I set this clear equals to false both times here. And that's because we are setting these macro variables with the symput here. And by default, the msource function will clear out the symbol table when it starts. And I don't want that to happen because that would wipe out my parameters to the template program. So I set that clear to false, and then that allows these macro variables to flow into the msource and set the parameters in the template. And then one other thing I did here, just to illustrate, is that I set this debug parameter to true and the symbol gen parameter to true. And that will run this particular example in the debugger. It's just another driver, different inputs with debug on. Let's go see what that looks like. Now, you'll see here in the console, I got a lot more stuff. So this is all the debug information. And this is really very interesting and very useful. So what is happening here is that you've got code coming in and you've got code coming out. The code coming in is listed here. The code coming out is listed here. And for every one of these input lines, this is the incoming lines, this is the outgoing lines. You can see very clearly which lines were emitted into the generated code file. So this one, this one, this one, this one. And then which ones were not emitted to the generated code file. And if we hit a macro variable along the way, the symbol gen tells us what the value of that thing was. And so you can see from this debug output quite clearly what the preprocessor is doing. And that can be very helpful when you're trying to debug the code. And then once the preprocessor is done, this execution section begins. And now this is just the generated code and any outputs from that generated code. So this is the thing that was produced, and then here's the output of that code. And just like last time, we spit out that generated code to a file. I can go look at that file and see now that this is completely different incoming data, completely different variables. I have 4 variables now instead of 3. Each one of those analysis variables created their own little block of code with each of the statistic lines generated by that block of conditional statements in the template program. And then all those data frames are combined together into a final data frame and it's printed. And again, this code will run all by itself now. You don't need the macro package anymore once the code has been generated. And so this is a quick overview of the macro package.